In this lesson, we will learn the concept of Avogadro's number, and we'll also be doing some calculations based on Avogadro's number and moles. Avogadro's number was first given by the scientist. His name was Avogadro. Um, he said that if you take a substance, any substance like CO2, water, carbon, sodium, any atom or molecule or ionic compound, and you take 6.022 times 10 to the power 23. So if you take this many particles or units of any substance, we can call that 1 mole of a substance. All right. Just like 1 dozen mean 12 things. Like for example, 1 dozen apple mean 12 apples, 1 dozen pencils mean 12 pencil. 1 mole of any substance means this many particles, 6.022 times 10 to the power 23. For example, if you have carbon dioxide molecule, this is a single molecule. Now, somehow you manage to get this many molecules of carbon dioxide, 6.022 times 10 to the power 23. So this is a big number. So if you collect this many CO2 molecules, we'll say that there is 1 mole of CO2. 1 mole of CO2. So 1 mole of anything is equivalent to that number. Now, that number can be represented by N, A. Both are written in capital, but A is written in smaller font. So NA here, A mean Avogadros and N mean numbers. So whenever we say Na with capital A, not small a, which is sodium, so Na mean this is this number 6.022 times 10 to the power 23. All right. So this is Avogadro's number. Any substance, if you take this many particles of that substance, this many molecules, this many ions, that will be equal to 1 mole of that substance. And 1 mole or mole is represented by small n. All right. Now we'll see some relationship between mole and Avogadro's number. So we learned that Avogadro's number, which is written in short as Na, is 6.022 times to the power 10 to the power 23, and it is equal to 1 mole, and mole is small n. So we can write a relationship, a formula between the two. We can say that capital N, I'll explain in a minute what is capital N, is equals to N times Avogadro's number, which is Na. Now, N here is number of units or number of particles. The only capital N means number of particles. What does that mean? Particles could be molecules, formula unit, ions, anything. All right. If I say that 6 point, how many particles are there? How many molecules are there in 2 moles of CO2? So N is 2 because mole is represented by small n. So 2 moles of CO2. All right. So Na is fixed number 6.022 times 10 to the power 23. All right. And this will give me N. N is what? The number of molecules of CO2. All right. So 2 moles of carbon dioxide would be N. So N is number of which becomes 1.2 times 10 to the power 24 molecules of CO2. All right. So using this formula, we'll do some more questions. Let's say we have this question. So as you read the question, I want you to pull out what is capital N, what is small n, or what is Na. Na you should know already. So calculate the number of water molecules, because it says that number of water molecules number of water molecules, it means that this is N. So they want you to find capital N, because number of molecules, number of atoms, number of ions, anything which is number of these units, it is capital N. So capital N is question mark. And what is given to you? The moles. How do you know that moles are given to you? Because the unit is mol. So we have this formula, N is equal to N times Na, which is Avogadro's number. So N is question mark, that's fine. And small n is given to you 0.5 times 6.022 times 10 to the power 23. So simply use this formula, and that becomes 3.011 times 10 to the power 23. Now, what are these? Number of water molecules. So in the end, after writing this number, you need to say H2O molecules. All right. So this is the N, number of particles. Let's try another question. All right, this is very similar example. Again, they're asking you to calculate the number of CO2 molecules. So again, question mark is N, capital N they want you to find, and 3 moles small n is given to you. So use the same formula, N is equals to N times Na. All right. N is given to you 3, and Na is 6.022 times 10 to the power 23. Now 6 times 3 is 18. In scientific notation, we don't write as 18, we'll write 1.8. So when we write 1.8 times 10, it, because we moved decimal point to the left, so that's become 24. All right. So N is equals to, you use your calculator and should be able to write scientific notation. So N is 1.8 times 10 to the power 24 CO2 molecules. All right. You need to mention that what did you find. So we found CO2 molecules. So this is the simplest way of using this formula. Let's do a few more examples. This question is slightly different. Why? Because they've given you the number of oxygen. They've given you number of oxygen. O2 is a molecule. Or they've given you number of oxygen molecules, but they're asking you to find oxygen atoms. Remember that one O2 has 2 oxygen atoms. All right. Each O2, just like a bicycle, has 2 tires. So O2 is a whole molecule, but in that O2 is made up of 2 oxygen atoms. All right. So we can say that 1 mole of O2 is made up of 2 moles of oxygen atoms. So this is a molecule. All right. So this is a molecule, and this is atom. All right. So in one O2, there are 2 oxygen atoms. So in one O2 molecule, there are 2 oxygen atoms. So we need to remember that, and we can slightly modify the formula. So if you want to find number of atoms, first of all, you need to have the moles of the molecules. All right, I'll write small here, no, moles of the molecules, and time it by the moles of atoms in that molecules. All right. And then Na. So slightly modified the formula. Now let's say this one, they want you to find number of atoms, so N is question mark. So how many moles of molecules are given? 0.5 moles of O2. Because O2 is a molecule, so 0.5 mole is the moles of oxygen molecules. Now, in each mole, how many atoms are there? There are 2 atoms, all right? So a number of moles of atoms in each O2 is 2. All right, we'll keep this. And then 6.02 times 10 to the power 23. So this will give you basically the same number. N is equals to 0.5 multiplied by 2 becomes 1, and 1 multiplied by this number is same number, 6.02 times 10 to the power 23. Now you need to write that these are oxygen atoms, not molecules. All right. So this was a little bit tricky, but you need to do it this way. So we'll see some more examples like this one. Okay, in this example, calculate the number of chlorine atoms. All right. Again, they're asking for N, but this is a number of chlorine atoms in the whole thing. All right. So we will know that this ionic compound aluminum chloride is made up of 4 atoms, 1 aluminum and 3 chlorine. So which means that each 1 mole of AlCl3 has how many atoms of chlorine? 3 atoms of chlorine. All right. So we use the same formula N for the main whole compounds and for the compounds. All right. And then number of atoms in 1 mole of that compound, and then Na. All right. So N of the compounds given to you are 2 moles of AlCl3. Because they says 2 mole of AlCl3, it means the whole compound is the 2 mole is for the whole compound. So we'll write 2 here, and then we know that in each mole of aluminum chloride there are 3 moles of chlorine atoms. So N of atoms in each mole, there are 3. And Na is a fixed number, 6.02 times 10 to the power 23. All right. So 2 times 3 is 6. 6 times 6 is 36. So instead of writing 36, we're writing 3.6. All right. Because this is the way of writing scientific notation. 10 to the power 24, because in 36, the decimal point was here, so we moved there. All right, so we need to increase 23, 24, so we write it 24. All right, so N is finally is 3.6 times 10 to the power 23. But now these are these are number of chlorine atoms, so you need to write chlorine atoms. All right, so this is the answer. All right, this question is slightly different now. In the previous question, you were asked to calculate capital N, the number of molecules. But here the capital N is given to you, and all you need to do is to find number of moles. It says here, calculate the amount in moles. So this is question mark, small n. You need to find. And what is given to you? Made by 2.3 times 10 to the power 21 molecules. So the number of molecules given to you, this means N is given to you. So the normal formula we use is N is equals to moles, which is small n, times Avogadro's number. All right. But we are not trying to find capital N. That is given to you. We're trying to find the small n. So we rearrange the formula and make it N is equals to the capital N, which is number of molecules, divided by Na, which is Avogadro's number. The number of molecules given to us are 2.3 times 10 to the power 21 divided by Avogadro's number, which you should know by now, 6.022 times 10 to the power 23. When you put these values in your scientific calculator, the value of N comes 0.0034. Now this answer is okay, but it's best to have the scientific notation when you're doing calculations with Avogadro's number. So right now the decimal point is here. we want to take it to the first non-zero digit after the first non-zero digit. So we take it step 1, step 2, and step 3. So bring it here. So n becomes 3.4 times 10 because we moved 3 steps, 1, 2, 3, so minus 3. And after the number you write MOL. So this is how you find number of moles of H2O when the number of particles are given to you. All right. So I hope you understood this topic, Avogadro's number, and try to do some more questions from your book. And if you're still confused, watch this again and again, and I hope it will make sense. And thank you very much.